Hey guys, welcome back. So today we're going to do exponents and radicals. So yeah, starting. So the first law is, it's really easy, like you guys would mostly know it. It's x power 1 is equal to x. So anything to the power of 1 is equal to that number itself. Like you can go like, yeah, I'll just make an arrow. Or like 4 to the power of 1 is equal to 4, or 5 to the power of 1 is equal to 5. Yeah, that's pretty easy. Then there's another law, x to the power minus 1 is equal to 1 by x. So the minus actually reciprocates the value. So anything to the power minus 1 is the reciprocal of that value. Like, just I'll give you an example here. So if it's 1 by 2 to the power minus 1, it would be actually 2 because it is reciprocated. And if it's 2 to the power minus 1, it would be 1 by 2. Because you see it's reciprocated, like the denominator turns into the numerator and the numerator turns into the denominator, because 2 is actually 2 over 1. So yeah, going on with the laws. So another law is x to the power 0 is 1. So x is any real number. Any real number to the power 0 is 1. Any number to the power 0 is 1 actually. So yeah, anything like you can give like 1000 to the power 0 is also 1. It's just a normal rule, you can easily remember it. Anything to the power 0 is 1. Yeah, so when two same bases are multiplying, this is the rule, x to the power m into x to the power n is equal to x to the power m plus n. So when two values with the same base are multiplying, so x is called the base here and the other called the exponents. So when two values of the same base are multiplying, so the resultant is a value with the same base but the sum of the exponents. So just giving an example of it, so we can take 2 to the power 5 into 2 to the power 7 is equal to 2 to the power 12. And even if you multiply it, it would come out that way. So yeah, it's just like, if it's difficult to remember, you can just remember it easily like this. 2 into 2 is equal to 2 to the power 2, because 2 to the power 1 into 2 to the power 1, 1 plus 1 is equal to 2. That's pretty easy, an easy way to remember it. And other thing is this, x to the power m. So like as we see here, it's m plus n. So when same values with same bases with different exponents are being divided, so the exponent in the exponent here, the exponent in the down, it turns into minus 1, because as you see this rule, x to the power minus 1 is equal to 1 by x. When it comes back up, it turns into x to the power minus n, and then you again apply this rule, so it's just m minus n. So we can go like 2 to the power 2 divided by 2 to the power 7. So we have to put a minus with this value and a plus sign obviously with this value. It would be 2 to the power 2 minus 7, because it's in the lower side. So 2 to the power 2 minus 7 is equal to 2 to the power minus 5. Yeah, it would be 1 by 2 power 5. So yeah, it's easy to remember because it's related to this and this rule. Yeah, that's it. So yeah, going on. Yeah. So an easy way to also remember it is like, you can go like 2 divided by 2 is equal to 1. So it's basically 2 to the power 1 divided by 2 to the power 1 is equal to 1. And so when you go 2 to the power 1 divided by 2 to the power minus 1, you get 2 to the power 1 minus 1, which is 2 to the power 0. Relating it to this rule, this one, so it becomes 1. So hence you get this. Yeah, going on. Yeah, just whatever. So if the exponent, if the whole value is raised to some power, the value itself has some power. Like, I'll just give an example. It's like 4 to the power 2. So it's actually 2 to the power 2 to the power 2. So the values, the m and n, would actually multiply over here. It would be 2 to the power 4. So these values would multiply. That's just a rule of, that's just something you have to remember, the additions and multiplications. So yeah, That's it. So yeah, when two different values, like it could be this rule, I'm talking about this rule, when two different values are being multiplied and they have the same exponent, the exponent is like given to both values. It does not make that much sense. I'll give an example. So yeah, 3 into 9, no, I haven't 9, 3 into 5 to the power 7. So like that. It would actually be 3 to the power 7 into 5 to the power 7. Like the power would be, both the values would be raised to the power because it's multiplying inside. If it's adding, that's different identities and all. But if it's multiplying, this thing goes on. The power is given to both values. Yeah, the last rule is, it's pretty easy though. It's like, it's just this rule, but yeah, it's this rule because, you know, division is just multiplication with the reciprocal. You can just remember that it this way. It is basically, division is basically x into 1 minus 1 divided by y. So it's basically multiplication but with the reciprocal of the value. So the same rule applies. It's just, it'll just go to x to the power m into 1 by y to the power m. So as 1 to any power is equal to m itself, is equal to 1 itself, so yeah, it would be 1 to the y power m. Hence it would give you x to the power m divided by y to the power m. My writing is a bit bad, but I hope you understand it. So yeah, let's take a line over here. Another very important cheat in important thing in maths, like in it's a rule in general mathematics too, but in SAT it is like given importance a lot. Like when it's written minus, I'm just doing this over here. So when it's written minus x square, it's basically like if you just substitute a value for x, just go like 2, it's minus 2 square. It's actually minus 4. You might be thinking it must be like 4 or something, but actually like if there is no bracket around it, nothing will happen. Like it's just that simple. Like minus square is plus, that's a given because minus 1 into minus 1 is equal to plus 1. So here, if there's a bracket, only then you apply the square to the sign, like the minus sign. If there is no bracket, the minus goes as it is. So it's basically, if it's without the bracket, it's minus 2 square. And if it's with the bracket, it's minus 2 whole square. Just take it that way. It's basically like, you know, you can actually divide things. So if you have any value like y, it's minus y. You just divide it into two parts, minus 1 into y. So if there is a value on y, like if there's a power on y, it would go minus 1 into y square. If there is a value on the whole, then you know what to do. Like this rule, applying this rule, it's basically minus 1 whole square into y whole square. So yeah, it would just turn out to be y square because minus 1 square is 1. So yeah, that's it for exponential radicals. I'll just be doing other stuff after this. So yeah, thank you.